Hi everyone, welcome to this session. Today's session we learn about the how to control a DC motor using NI USB DAQ 6001 and the motor controller H bridge. So the motor controller H bridge can generate the PWM signal for the DC motor power and the DC motor torque generate, and the motor controller H bridge is 4 power MOSFET contained and it can generate the current to the DC motor and alternate the generate the motor voltage and speed and direction. It's either one direction and changing adaptable other direction. So moving to our LabVIEW programming software, so here we can graphical outline generate for the motor controller using NI USB DAQ. So at first into the block diagram, so right click on this block diagram window and going to the measurement and then go. So moving to our LabVIEW programming software, into the DAQ assistant you can find the DAQ MX create virtual channel.vi. So in this selection area you can select the digital output and the DAQ MX create the line. So we can need to the selection, so create the control for IO channel, need of selection. So previous icon, then we proceed to our DAQ MX write.vi. Here you can select the analog to digital, into the digital the single channel single sample 1D boolean NSAN. So the task in connected to the write.vi function task in and error signal can connect it. After this, the measurement IO again going to the DAQ assistant. Into the DAQ assistant you can find the DAQ MX start dot tasks, and then is connected to the DAQ MX write task out is going to the DAQ MX start, and the error signal can be joined. After that operation, going to the function palette, into the function palette, going to programming the structure, you can select while loop. So I choose here the while loop, and then into this while loop again a structure can define. I choose the case structure for generating the PWM signal. In this operation we generate the PWM signal as a now NI USB DAQ can't generate the PWM port having any PWM port, so we can generate the PWM signal into this way. So after that the motor can be run, the DC motor can be done using NI USB DAQ and the motor adapter bridge. So into the case selector, into the case structure, so here we going to the measurement IO again the DAQ assistant, and then going to the DAQ MX write.pi. So select here digital single channel and sample 1D boolean. So after that you can select into the DAQ assistant, you can find the DAQ MX create virtual channel.vi. So in this selection area you can select the digital output and the DAQ MX create the line. So we can need to the selection, so create the control for IO channel, need of selection. That then we select this line is DAQ MX, the total function can be pasted here, then it's connected to the task out and again going to the DAQ MX. This after that the error signal can be also be connected. Then you connect this wire into the DAQ MX channeling, and the case we will select here, right click here, going to numeric palette equal and connect it to here. After that this selection will, here we can approach a formula or right here create constant 1. Then going to the numeric palette, select here this one, and its iteration I is connected to here. Create constant 2. This condition will apply for this one. So after that, here again measurement going to the again the DAQ assistant, the clear the task here, and it is connected to the task out, and the error signal also be connected. It is the true base structure, and then the wait millisecond we pasted here for the true create control that low for the false condition of this case structure. Measurement DAQ assistant, then write.bi, sorry for not going to function palette, measurement IO DAQ assistant, write.bi select. Here you can select digital single channel single sample 1D boolean format. Connect the task out to the here, and the error signal can connect it. Again you connect the task out here, connect it, and wait millisecond here I is selected. Create control, the wait millisecond is high, and then we lastly add our DAQ assistant. So going to express in input, then DAQ assistant here, and configure this DAQ. So first we need to connect our DAQ hardware NI USB-6001 into the PC. So connect. After the connection, a window that generates the device detected NI USB-6001. Configure and test this device. Going to the NI Emacs driver. So a window can generate that acquired signal or generate signal. So here we select the generate signal, then the digital output, line output that we select for this one, the port 0 line 1 USB 6001, the DIO part, that port 0 line 1, and then click finish. It is generation mode 1 sample on demand. Then click OK, and building.vi. After this, then we can go into the create here. Right click the create control. So this an array format. So you can choose it is binary form. So delete here, and going to boolean control palette, into the boolean function you select a round LED for this. So it need to connect, create indicator, create control. It's format as indicator, create control. Need to remove. Then it's connected to the data DAQ assistant. So it's not connected because the two different data types. Here is error showing. So showing that you have connected to two terminals of different data types. The type of the source is boolean, true or false. The type of the sink is 1D array of the boolean. So we need to build an array of this here. So going to the function palette, right click here, going to the function palette, into the array, we need to build an array, this function here, and connected this boolean function to one end the build an array and another end connected to the data, the sink. So this is the channel mode for the selection of PWM, and this is the channel that DAQ assistant output can generate to control the DC motor. And this is the case structure. If we need this false, then the high milliseconds, and it's the true, the low milliseconds, and select it. And the operation here, some condition pasted here, and after that we create control in the while loop control part. So going to our front panel window, here select your line. So device 1 port 0 line 1 or port 0 line 0 in this device. So is select the hardware selection, that device 1 port 0 line 0. Device 1 is the device name, and port 0 DIO port 0, and the line 0 the port number. So and line 1 we here the select for DAQ assistant data. So after that we run this operation. So create here some error showing the DAQ MX right VI required the input data is not required. So going to the block diagram again. Here right click the DAQ MX right, need to require the create constant, and here also wait. After that is operation, going to front panel window, then we run this window. Going to the front panel window, here you can select the line channel line, the device 140 line 0, and the low ms, low time millisecond, and high millisecond are shown here for the motor, and the direction of the this function, the boolean, and we run this operation. So after the run, motor will be moving on one direction. If we select this low ms, the value can be changeable for the motor, and we need for the reverse direction of this motor, select the boolean, it can be done. For hardware demonstration, that's how to control a DC motor using NI USB DAQ 6001, and this is our H-bridge controller board. And this H-bridge control board that has 4 power MOSFET, and it is controlling the DC motor speed, torque, as well as the direction, and provide the PWM signal from H-bridge to the DC motor. And this is our NI USB DAQ. We said again the previous videos that USB DAQ, it is a multifunctional DAQ device, that this side screw terminal is analog channel and this side is the digital channel. So we task about the digital channel, that PO port number 0 line 0, this the orange cable going to the motor H-bridge board generate PWM signal, and this the blue cable, that's PO port 1, that's going to the 3.3 voltage generate, and the yellow cable, it's connected to the H-bridge motor board, that the ground terminal, and these two wires, the black and this wire, and this is this black wire is ground terminal, and this is the 5 volt terminal power voltage, and this point gets the motor power that required to this motor to rotate, and this is required power is 9 to 16 volt. Here we provide the 9 volt battery DC power voltage. So we put this NI USB DAQ and connect it to the laptop. So again we run this program for this demonstration. So at first we run. So here motor time speed is 2 and time load is 7 millisecond, and we can change the direction of motor. So in this way we can change the direction, both torque and the motor speed. Thank you for watching this video. Please subscribe our channel E-Innovista.